Okay, welcome to this video on exercise 1C, reciprocal functions, and 1D, radical functions. So these follow on from 1B, right? Remember in 1B we talked about inverse proportion. So inverse proportion is the proportionality that we learnt about in 1B, whereas here we're looking at the functions that follow that form. So remember, if we have y equals k on x, one thing we can do is multiply both sides by x, and we'd obtain k, which is some number, is equal to xy, okay? Every possible combination of x times y, every possible coordinate of x times y is going to obtain the same value of k. So here's the graph of 1 on x, and we're presented with all of this information about it. And this is going to be the case for all reciprocal functions. It has two branches, okay? So you can see the first branch here and the second branch here. It's undefined when x equals 0. And that means it's undefined for all of the y-axes, okay? It's undefined all along there. And what that means is the function doesn't exist there. It has what we call a vertical asymptote. It doesn't exist because you've got, if you consider the function y equals 1 on top of x, 1 divided by x, and if x is 0, 1 divided by 0 is undefined. If you put that in your calculator, you're going to get a math error. And we might have a bit of a conversation in class about why that is the case. But 1 divided by 0 is going to be undefined. So it exists in the first and third quadrants. The graph gets closer and closer to the horizontal line, y equals 0, but never reaches it. So if you just go along here infinitely, all right, we've got x is increasing forever. And if you keep going along in that direction, this graph will never touch the x-axis. It'll get what we call infinitely close, but it's always going to be a little bit further away. Okay, so that means there's an horizontal asymptote, so it doesn't cross the x-axis, it gets infinitely close to it. And similarly, going in the negative direction here, this arrow is going to get infinitely close to it as well. So we have a horizontal asymptote at y equals 0. And then we have the same characteristic happening vertically. As it comes down, it's getting closer and closer and closer to the y-axis, but it's never going to touch it. It gets infinitely closer to the y-axis, but it's never actually going to touch the y-axis. And then the same going up in this direction as well. So we have a horizontal asymptote at y equals 0, and we have a vertical asymptote at x equals 0. That's what those two paragraphs are saying. So we will have a conversation in class as to why we can't divide by 0, but for now, let's look at how we solve these problems. Firstly, it's going to be about graphing, right? So if I can just do a very quick recap of graphing, we've got some functions here. So in your menu, you'll go down to graph, and what we're going to do is we're going to input some function. Let's just put in the 1 on x function. So the ABC button brings up a fraction, right? And I can put in there 1 on top of, and whenever we've got a variable, we're going to use this button, x theta t. And then we press execute to say, yep, I'm finished typing in, and then we press execute again to graph it. So yours might look like this. It might look a little bit different depending on what your V window is. So pressing F3 will bring up your V window. And these are the constraints of the Cartesian plane, right? You're looking at the graph and you've got what's called a V window. It's your virtual window of which you're looking at the Cartesian plane. Here's your X min, here's your X max, here's your Y min, and here's your Y max. For our general purposes, generally the standard setting will be enough. Okay, so you can press F3 to set it to standard. You can see there's a couple of other basic ones here. But for our purposes, generally standard will be enough, although sometimes you will need to change it and zoom out a bit. Okay, so I've got it standard now, 1 on x. There's the function, we can see it. And we can see it's getting closer and closer and closer to the y-axis, but it's never going to reach it. It's never going to obtain it. Okay, so what I do is with the graphing questions, I encourage you to use your calculator to support you to help you sketch these graphs. Another feature is you can trace along it. So you can press F1 to trace, and you can trace along the graph and see the crosshair. It tells you the coordinates of those points. So that might be helpful if you're sketching it on grid and you want to do a very meticulous sketch of the graph. If you want it to be very precise and accurate, that can help you because it lists the coordinates for you of the point that you're tracing. Okay, so one of the first questions in this exercise is, what's the equation? Is sketching graphs, sorry. The second type of question is, what's the equation of this reciprocal function? So here I've got a reciprocal function that passes through this point. X is -3, y is +1, okay? It passes through this point. Well, remember, if it's a reciprocal function, it has this form, which means this statement is true. K equals x times y. So k is equal to minus 3 times 1, which is minus 3. All right, minus 3. And so therefore, the equation of this function has the form y equals k on x. K is minus 3, so the function is going to be minus 3 on x. Let's confirm that's true. I can go in here and I can change this function just using my directional pad. You can delete it. Minus 3 on top of x. Let's graph it. Okay, it's got the same properties of this one. All right, same function. Okay, let's skip up to 1D here where we've got radical functions. Now, radical functions are quite similar. The only significant difference is going to be this denominator. All right, so the denominator is what's at the bottom of the fraction. We have x take b. So it's going to have the same shape, right, except it's shifting it horizontally. It's moving it to the left and to the right. And so we're always going to have what we call the vertical asymptote. That's going to be at x take b. It's going to be at x is equal to b. All right. So in this circumstance, we have 3 on top of x take 1. The vertical asymptote is going to be at the number 1, x equals 1. So let's observe that on our calculator here. 3 on top of x take 1, we'll graph it, and we can see it's shifted across. You can see the line x equals 1 is here. That's the line x equals 1, and we've got that's where the vertical asymptote is occurring. Okay, if I put in x take 2, it's going to shift it across even more. All right, you can see it slowly moving across. Let's go to x take 5 to dramatically shift it across. All right, it's moving it across. So that's going to be the equation of the vertical asymptote. So again, in this exercise for 1D, what we're going to do is we're going to rely on our calculator a fair bit. So I'd encourage you to use your calculator, become familiar with it, with the input, with changing the V window, with tracing along it. The way we're going to illustrate the asymptote is with a dotted line, okay? And then we're going to call it x equals 1 or x equals 5, or wherever its respective location is on the Cartesian plane. So 1C and 1D, I don't want to see it bogged down in this exercise. It's one I'd like us to use our calculator for, to sketch some of those graphs and just be confident with the calculator graphing process. Cool.